we buy the vehicle, we fix the vehicles, we sell the vehicles, and then we also finance and service the loans, the auto loans. So some 2019 numbers, we have 138 dealerships across the country. This past year we had 2.3 million leads, which led to 125,000 vehicles sold. We spent $1.2 billion purchasing the vehicles. Once we purchase the vehicles, then they go to our inspection centers. We have 20 inspection centers across the country, and that's where we fix the vehicles and get them ready to sell. And our servicing department, we have 400,000 loans with a value of $4.5 billion. So that's DriveTime. So we got into Snowflake about a year and a half ago, and our situation before we had Snowflake, we've done a lot of different projects in Snowflake, but we believe this project with marketing is a very good example of where Snowflake adds value. So we have our online site, drivetime.com, and that's where the customers can go to look at vehicles that we have, search for vehicles in their area. They can schedule appointments for the dealership. They can submit some of their information where we'll actually pull their credit and then show them what their down payment would be. So through this, we collect all of these web events, and we have about 1.2 billion events right now. And so before, we had some major pain points because we were doing this on-prem through SQL, and we were doing all of the JSON parsing on-prem, and that would cause a lot of contention for our existing warehouse. And then we'd have challenges just querying and reading and integrating that data. And so Snowflake, once we moved all of this data up to Snowflake, Srini here is going to go into more detail on the technical side of where that went and how it provided value.
If you guys actually think about 1.2 billion rows, it's actually not that much when you think about from a big data size up there. But our pre-Snowflake architecture, which is all on-premise Microsoft SQL Server, all of those 1.2 billion web events actually sat in our cloud Azure Blob environment as JSON structures. So we needed to actually pull all of those JSONs down to our SQL Server, which was a staging area, raw format. And then so we used Polybase technology in SQL Server to pull all those events into our staging area. Then we had to set up frequent store procs and schedule store procs to actually pass those JSON structures into staging tables, and finally into a reporting structure, which was all facts and dimensions combined in there. Then we actually had to take all those 1.2 billion events and then aggregate into a tabular structure so that the analytics, which is essentially our end users, can actually analyze the usage patterns for all those 1.2 billion events and actually generate experiments and variations so that we can actually provide better customer experience on drivetime.com. So one of the things that we actually found out is SQL was very slow and inflexible. So to pull in all those events in and parse them was taking a lot of time, sometimes hours, 4 to 5 hours every day for how much we were doing. We could not actually scale the SQL Server database because it's pretty much fixed in how many cores we can actually provide it. The frequency was totally dependent upon how much network activity we could actually provide between the cloud versus the on-prem and SQL servers up there. One of the main things that actually hit us before we went to Snowflake was we actually created all this reporting structure on 1.5 billion events, and then the analytics came and said that, hey, we want to shred an additional data element in the JSON, which we did not shred on the initial backfill, and that was a credit grade. So we started to give an estimate of how long it's going to take us on the SQL Server environment, and then based on how long we have to actually read all the files back in, shred the data, put it into staging, then put it into a reporting structure, then aggregate into tabular, and finally to Excel was probably 1.5 months of time. At that point, we actually decided that SQL was not going to be feasible for us to actually do this, and we moved to a Snowflake architecture. And part of going to Snowflake was also to simplify this overall SQL Server architecture into like a much smaller one. And I'm just going to go a little bit high level, so if you guys have any questions, just type it out and we can actually go over that. So on a Snowflake, our initial sources are still on the cloud Azure Blob Storage, and we use Snowpipe, which is essentially an automated way of reading events as they are coming in, which is our streaming architecture, to read from the cloud storage and put it into Snowflake as the events are coming in. The latency is about 1 to 2 minutes. Once the events are actually available in Snowflake as a raw JSON format, we actually use Stream and Task, which are essentially like two more technologies available with Snowflake that can read incremental data and are able to schedule like automated programs to run every 20 minutes to actually shred the JSON and put it into a reporting structure inside of Snowflake itself. Now, rather than using Tabular and Excel, we actually now connected Tableau, which is our reporting tool, as a live extract on top of Snowflake, because on Snowflake, we can use the compute to actually get all this data real time, and then we don't have to spend time pre-aggregating it because like Snowflake is actually scale up and scale out. So what we got was essentially like a very simple solution. Essentially, we could scale up and scale out, and it's actually all live data, essentially. And also, at that point of time, we were just kind of like going through like how can we utilize Snowflake. We can actually use Snowflake as like all-in-one data warehouse at this point of time. And we are going through a project of migrating most of our data sources into Snowflake. Also, analytics, they were all on-premise. Now we are actually making them go to the Snowflake environment so that they can actually use the compute of Snowflake and also the storage of Snowflake, which is pretty cheap, so that everybody can have access to the data and we can decrease the conflicts so nobody's fighting with each other. And we are also leveraging a lot into the streaming architecture on Azure Event Hub, because now our development is not like a month-long development. It's actually, it can be measured in days. And one of the other things that we are trying to do is data sharing with third parties. Third parties had access into our on-premise SQL servers. Now we can actually use the data sharing with Snowflake to actually have them only access the data they actually we can share with them.
And just a little plug here, we have some open positions at DriveTime, so anyone out there that wants to develop in Snowflake, check out our career site. So now we're going to pass it off back to Joe, who's going to handle all of the questions for us.
Great, thanks. So I guess a couple questions have come in. The first one is just, can you walk us through sort of your evaluation process of why you chose Snowflake over other data warehouses? And then kind of woven into that would be, how is Snowflake different than other data warehouses?
Yeah, sure, absolutely. I mean, before Snowflake, we had like other big data projects that could not utilize SQL Server on-premise technology. So we went through a lot of POC process. So we vetted out Google BigQuery, Amazon Redshift. We looked at Hadoop technologies. We looked at Cube on top of Hadoop technologies. So, and then all of them, including Microsoft's parallel data warehouse in the cloud. Most of them either required a lot of learning curve, or they required a lot of like upfront investment, or just kind of like it did not pan out. Like one of the other things that always just kind of like missing from our evaluation, and then we did not feel comfortable with any of those technologies because none of them were simple enough to implement in our current DriveTime environment. So as we were going through Microsoft Parallel Data Warehouse, we actually found Snowflake as kind of like somebody just brought up like, hey, what is Snowflake? And then we tried to do the exact same process on Snowflake that we did with Parallel Data Warehouse, which is essentially to load a terabyte of files, split up into 600 files, and then see like how fast we can load those files from a Azure cloud environment or an Amazon S3 bucket into like our target like warehousing environment. And Snowflake literally blew it out of the park compared to any other technologies for like a fraction of the cost. So Snowflake actually met our cost per part of the evaluation purposes, as well as when it comes to like scale up and down, and as well as kind of like there are like multiple features of Snowflake that go with it, but our most bang for buck is actually scale up and scale out, and essentially how fast like we can actually have the queries written back and how much we can store on Snowflake without having to worry about like getting into performance issues.
Yeah, this is Peter as well. I'll just add a couple things. One of the things about Snowflake was, as Srini mentioned, was also the administration side. With the parallel data warehouse, there was a lot more administration, partitioning, and indexing that you had to implement to gain the speeds that were comparable to Snowflake. With Snowflake, we really had no administration that we had to deal with. The other piece of the evaluation isn't just about developers and technical, but the consumers on the other end. Our consumers, which is primarily going to be analytics consumers, in our organization, they're very well equipped in SQL Server and writing ANSI SQL. So the Snowflake lent itself really easily for getting them up to speed with how to use it, log in, and basically get up and running in a number of minutes, hours, days versus kind of weeks and months as far as training and the learning curve. So that was another big piece of the evaluation.
Great. So another question, actually a couple questions I'm just going to sort of consolidate, but folks wanted to know, are you using an ETL tool in conjunction with Snowflake? And if so, what is the ETL tool or tools?
We were using SSIS before, so there's two parts to this answer. Before the streams and tasks, which are actually Snowflake technologies that became available probably like 3-4 months back, we were using SSIS packages to move the data from our on-premise servers onto Snowflake or from cloud sources onto Snowflake. And that was pretty cumbersome because Snowflake is only one API SQL call per, essentially. So you have to code a lot of like dynamic SQL to actually kind of like call the SSIS packages. And once streams and tasks and Snowpipes became available in Snowflake, now we have a really simplistic approach. Snowpipes can actually connect to a lot of different data sources, and you can actually load through Snowpipe, which is a real-time data ingestion platform with this is literally 4 lines of code. You can load the data into Snowflake, and from there, once it lands into Snowflake, you can use streams and tasks, which are actually reading incremental data sources from the tables inside of Snowflake, and you can create store procs, and you can actually schedule them inside of Snowflake. Our other piece of the answer is essentially you have a lot of sources which are actually available on-premise. How do we actually upload them to the Snowflake environment so that we can create a data lake kind of a mechanism up there? So right now we invested in a tool called Stream, STRIIM, which is going to enable us to read change data capture off of SQL Server and then populate it real time into the Snowflake environment. But let's say if somebody does not have a tool called Stream, then we would actually have to use like whatever your enterprise ETL tool would be, whether it's like SSIS or Informatica or data stage up there, you guys would have to actually code it up and then kind of like transfer the data from on-premise to the SQL Server environment.
Great. So another question coming in was, what are the key lessons learned in ramping up on Snowflake? So you can talk to lessons learned in terms of technology, but also maybe people and process or politics and so on. The lessons learned.
Yeah, I would say some of the lessons learned were, get started sooner than later. The evaluation process does take a little bit, but for us, if we would have known earlier, we would have got started earlier. And then every environment is different, right? So there's not just Snowflake you need to learn. If you're an on-premise shop, you have to integrate with these other tools. And so we had to, learn a little bit late in the game exactly how we're going to evaluate these other products, like these ETL products. We went through about 6 of them to figure out which one fit, our needs the best. And then you have to get something up and running, I think, very quickly to get initial feedback in and get your analytics and your customer base using the product quickly. What we found is as soon as we got them in, we had our business sponsors for us, so that if we did need to, buy more credits the next year or expand our adoption or, build out the product base even more, the consumers generally tell the story or show the value in what you've put out there. And so they've been pretty crucial to us as far as our roadmap, our path. They're leading us down that path, and that's probably shaping kind of our next level initiatives, is really just getting that customer base in as fast as you can so they see the value or they see the difference in query time, response time, or rapid development with something like Tableau.
Yeah, I would actually add that like one of the other key learnings from just the technical side was how do you do development and testing versus what is the production environment? Like Snowflake is like one instance that you have up and running. How do you do like source control with it? How do you like organize data? Like when we started with Snowflake, we just kind of like started throwing data at it. Like all the projects where we just started throwing data. And now as more and more people try to adopt Snowflake in our company, we are kind of like, oh, it is not going to work. Like we just can't put the data and park it however it is. So there is a lot of investment that you guys need to do to actually come up with like how do you organize the data? How do you actually kind of like propagate like some production changes into Snowflake up there? What does like data lineage look like up there? Anything like Snowflake is actually a data storage platform if you actually really think about it. So a lot of thought process needs to go into kind of like how do you want to organize, how do you want to metadata it essentially. So based on however you actually have your development practices set, like it needs a little bit of different thought process when it comes to Snowflake, and we are going through that learning process right now.
Great. So another question rolled in, and this one's about cost actually. So it's how do you handle cost in Snowflake, and what do you do if an end user is running a very poorly written query that's using up a lot of compute?
I think we didn't hear the first part, but we heard the second part.
Oh, just basically how do you handle costs overall with Snowflake? And also then how do you handle a user who's written a poorly structured query that uses up a lot of compute resources? But the first part is about costs overall.
If I think I understand right, it's cost as well as poor query performance and how you deal with that, correct?
Well, one of them is just cost overall, right? Just to make sure it doesn't, people don't use too much credits. And the second one is around how do you prevent a user from running a poorly written search?
Yeah, from a cost standpoint, definitely something that's different than a lot of other platforms. And so, we thought that, in Snowflake, you can make these warehouses. They're basically compute sizes, and that's what you're billed against per second. And when you're using the tool, you're kind of starstruck at how big you can make these and how fast you can get queries to execute. But you can also quickly end up with too many of these compute warehouses. Maybe like Srini had 4, I had my 4, and we would move around. But when you really roll this out to a consumer base, to really maximize the cost, you really need to use those shared seconds or try to combine queries to run on the same compute to maximize that. So we're by no means done evaluating the best way to manage costs, but you do have to monitor it. It is, you take the place of maybe a traditional DBA, that would be really looking at, things like disk space and query optimization. Now you need to really focus on cost, as well as some queries, and I'll let Derek talk about that in a minute, but you do have to dedicate time and effort into trending and looking at costs and then evaluating different methods or combining warehouses where maybe you thought everybody got their own. It's definitely something that comes up relatively quick after you go live.
Yeah, and as far as managing the users goes, we've had a few instances where some analytical users have had some kind of rogue queries that ran for a while and costed some credits. So there's been a bit of learning of that. We've built some custom dashboarding in which we can see which users are running what queries and how much credits those are taking. And learning from that, we've kind of shown that analytics really only need like an extra small or a small depending on the queries they're using. And we can kind of manage that by using the roles in Snowflake. So our analytics have a certain role which only have access to certain warehouses. And we do have a bit of a learning too on some long-running queries. So that was just a bit of a learning curve we had to go through, and we've got it kind of fleshed out now.
And I don't think there's any way to prevent anybody from writing a bad query. Snowflake does not give you a compilation plan before you run the query. It only gives you after you have actually run it. And I think they are working on actually getting it done. Optimizing a query, if that's what you guys are thinking, is also pretty easy on Snowflake because it exactly tells you which part of the query is taking the most time. So if you look at the execution plan afterwards, you know that I need to tweak these 2 lines of code and then kind of like get it to run faster up there. And I think this is pretty easy, but the overall answer is like you need to monitor, you need to actually be aware of those, and then you need to fix it quickly. Otherwise, people just keep on running in the same time.
And I believe Snowflake has some built-in config for like if your credits go over a certain amount, you can like just basically cut it off. So you could do some hard alerting or config to set to like limit credit usage.
Resource monitors.
Yep.
Yep. Yeah, so we just touched on there. We do provide resource monitors, and those can be used to impose limits on the number of credits that a warehouse is consumed within a specified interval or date range. And when those limits are reached or getting close, the monitor can trigger various actions, such as sending an alert notification or even suspending the warehouse. So that's another step that could be taken to make sure credits aren't being, excessively used too fast. All right, so let's see here. Next question is, there's a couple of related questions. Try to combine them into one. But the question is, what data modeling tool are you using, if any, and what was your data model in Snowflake?
We do not have a data modeling tool in Snowflake. Right now, we heavily utilize denormalized. We try to put as much data into one table as possible in Snowflake because it can absolutely handle it. If you actually think about Oracle versus SQL Server databases versus Snowflake, the on-premise database technologies actually prevent you from querying big tables efficiently, but Snowflake does. So a lot of the complexities of on-premise data modeling wipe away with Snowflake, where we can actually utilize rather than having 3 fact tables, I could have 1 fact table which is pretty big and long essentially, right? Essentially, and Snowflake can actually shred it and kind of query it and aggregate it extremely fast up there. One of the tools we have, it's called DB Schema. That we have utilized, and that actually gives us a way to actually model the tables inside of Snowflake, and it actually gives you the metadata of that in a visual way up there. But apart from that one DB Schema tool, we don't have a official schema modeling tool right now in DriveTime.
And just to add to that, with the JSON parsing and how good Snowflake is at it, we store every piece of JSON possible. And then what we provide to the analytics and the people reading from it are just views or tables with specific points of data that they need. But if they ever need anything else, we can go back to the beginning of time of us storing this JSON and just grab whatever piece they would like.
Great. Next question, I think, probably has a pretty quick answer here, but how many different accounts of Snowflake do you have? Or I guess it actually could be different sort of instances as well, but do you have different dev and test and production accounts or different databases?
Yeah, so with Snowflake, you have an instance, and you can create your databases, I guess is the best way to describe it, in your instance. So you could do kind of a prod test dev type of thing there, and using the roles and permissions in Snowflake, have those treated like dev, test, and prod. As far as users, everybody has their own sign-in and password. We do have AWS and Azure instances, so maybe that answers your question.
Yeah, and like if you guys are thinking, do we have a official dev instance, test instance, and a production instance? That's what I was actually referring to before. Is kind of like the testing plan on Snowflake is a little bit different from on-premise databases. Like you can clone databases within seconds. So let's say you have a testing need and you want to develop something predictive. You can actually take a production database, multi-terabytes in size, clone it up, and then you can actually do your development inside of that. That's your spot instance. And then you can actually promote your changes to production and immediately destroy your spot instance that you created. So Snowflake actually gives you a little bit different ways in which you can actually do that if you don't want to have 3 instances up and running. Like in DriveTime, we only have 1 instance on Azure and 1 instance on Amazon.
Gotcha. Yeah, just to add to that as well, with a lot of our customers, they just have one account. They basically just sign up for one Snowflake account, and within it, they have tests and dev, and they have production, and they use role-based access control to limit who can see and do what. But for some organizations, right or wrong, they have to have different accounts for different maybe lines of business or different divisions. So in that case, they can have multiple accounts, but we do have something called we have a concept called organization. So you can have one organizational sort of object underneath it, multiple Snowflake accounts. So you basically get one bill, but for many Snowflake accounts. So that's another option. Just quickly, I'm going to answer one question is how does it auto shut off in Snowflake? How does that work? Do you have to configure anything? And I think what we're referring to is the virtual warehouses, making them auto suspend. And that's just a configuration you can do with the SQL command or in the UI. You can set it up to auto suspend so that if no one's running a query or there's no ETL job, those compute resources automatically suspend. If someone needs those resources, they automatically spin back up. So that's all automatic. Another question was, what kinds of platforms do you run on? We run on AWS, we run on Azure, and we also run on Google Cloud Platform. And I'll go back to another question that came in for the DriveTime folks. So the question is, do you do any JSON flattening?
Yeah, we do a lot of JSON flattening with our web event data. It all comes in a JSON string every event, and we parse through those and make our fact and dimensions based on that.
And I think the JSON parsing is essentially one of the highlights of Snowflake. Is like the parsing in Snowflake is extremely easy. It's kind of like it's very, very fast compared to any other technology that we have seen so far. So that's why we heavily use our architectures to actually kind of like say that, hey, just give us JSON and we can just parse it like in Snowflake straight up.
Gotcha. And so another question came in. I'll kind of take a stab at answering this. You can add to it. But the question is, do you deal with any unstructured data, and how do you deal with it? And as has already been answered, JSON is unstructured data, which DriveTime leverages. Snowflake can handle not just JSON, but also other types of unstructured data like Parquet, Avro, XML. So I guess for DriveTime folks, is there any other unstructured data you deal with other than JSON?
Avro. I mean, that's how our streaming data comes in from our Azure Event Hubs is through Avro. So we have like Avro and JSON right now.
Gotcha. Another question came in here is, it's very specific here. It says, were your original SQL servers on-premise or in the cloud? If it was on-premise, was there a performance issue moving data between Azure Blob and SQL Server?
Say that again, sorry, Joe.
The question is, were your original SQL servers on-premise or in the cloud? And if it was on-premise, was there a performance issue moving data between the Azure Blob and SQL Server?
Yep. So our SQL Server were on-premise, and our blob storage was in cloud, and there were performance issues getting the data from cloud to our on-premise because it actually consumes a lot of like memory and network bandwidth on the SQL Server itself. So it would bog down the complete server if we actually try to pull, like a very easy example is, let's say we wanted to pull a day's worth of events at the same time, it would run for hours. But if I would actually run like probably like 5-minute slice or a 10-minute slice, it would go through fine. So that actually tells you kind of like how much data we could pull at a time without an issue. And like if we have like any data growth after that time period, like SQL Server would just literally bog down in pulling this string through. I think Microsoft is still working through the poly-based technologies. I think they will probably make more strides in it, but like when we tried it, like, and we still have some poly-based in our environment and it's still very slow. So we have to be very careful how much we can actually pull.
Great, thanks. So this will be, just given we've hit sort of the 10:30 mark here, this will be the last question. For those of you whose questions did not get answered, I apologize. We apologize. We just had too many questions. We had a lot of questions come in. Unfortunately, we're not able to answer all of them. But the last question here for DriveTime is, maybe can you walk us through the migration process in terms of what was it like, how long did it take, and also did you use any external tools to help with the migration, moving over stored procedures and things like that?
So for stored procedures and stuff, it's pretty much copy-paste. SnowSQL is very similar to our T-SQL we were using. There was just little pieces here and there you would have to maybe replace. One example, I guess, is if you have a top in a view or a top 100 or whatever, you put a limit 100 at the end. Casting is a little bit different. Aliasing is a little bit different. But other than that, SnowSQL is pretty similar to T-SQL.
Yeah, I think like most of the projects on Snowflake were also like brand new from the scratch that we built, apart from the marketing example that we just showed you, where we had a complete inbuilt solution on-premise SQL Server that we wanted to migrate to Snowflake. And I think it took us about like 2 to 3 weeks to actually kind of like get the entire data set and the code set from on-premise and like migrate it to Snowflake. We did not use any tools. I don't think there are any tools that will migrate from on-premise to Snowflake as of yet. I mean, we may be completely wrong, but it was just us, like Derek said, we would take the code, copy-paste it to Snowflake, SnowSQL, and we will change the syntax a little bit here and there, and it will just work.
Great. So with that, unfortunately, we're now out of time, so that wraps up this office hours. It will be recorded and sent out to everyone who registered for this office hours. And I do want to give a big thanks to the DriveTime team for the great content and also to the audience for the great questions. We'll see you all at the next office hours in 2 weeks. And in the interim, I encourage all of you to visit snowflake.com to learn more about us and see our case studies and videos. And also on the homepage, you can sign up for a 30-day free trial of Snowflake. And when you do that, you also get a tutorial that walks you through how to load demo data into Snowflake and then quickly start running queries against it. So you have that aha moment of Snowflake very fast. So with that, thanks for your time. Appreciate it.
Thanks for having us.
Thank you.